Hello everyone. Welcome to our webinar. If you can hear me, if you will just type in the comments box that you can hear me, that would be awesome, just to let me know. We are really glad that you can join us. My name is Debbie. We're really excited about this webinar. Just a quick explanation here of how this works. You are all in listen-only mode, which means you can hear us, but we cannot hear you. Thank you for responding that you can hear me. That's great. We know you might have questions, and our hosts, Javier and John, will be giving you an email address to send those questions after the webinar, and they will do their best to answer any questions. So watch for that email address. The webinar is being recorded. You will be able to watch it again whenever you like. And I'd like to just introduce our hosts today. They are Javier Sola and John Iriberri. They are work partners. They are cycling insiders. They enjoy finding complex solutions for problems that appear at first to be simple. So they've got a lot to share with us today, and we're really excited to have them here with us. Javier is the CEO of Training for All. He works for Custom for Us. John is the CEO of Custom for Us. He's an expert bike fitter. He works for World Tour Lotto Jumbo. And so without further ado, I will give you Javier and John. Javier, I am going to switch the screen to you so that you can take it away.
Okay, thanks Debbie. I think that all of you can see my screen, I think.
Yes.
Yes. Okay. Thank you very much for the invitation. For John and me, it's a really honor being here. And the topic of today is cycling and asymmetry. About us, I'm Javier Sola. I work as a coach and teacher from master cyclists and professional cyclists and trial leads. And I work for Custom for Us. And my partner John is going to make the presentation himself. John?
Yeah, thanks Javier, thanks to everybody for attending, and Training Peaks for inviting us to giving this webinar. I work as a bike fitter for Lotto Jumbo, and I run my own company, Custom for Us, very focused on bike fitting and cycling and running biomechanics. And we will try to share our experiences in fitting related with today's topic, that is the asymmetries in cycling. So you can go on, Javier, please.
Okay. Well, what is the background of this? As we have said, we work as fitters, and we have found that lots of the problems on injuries that have the cyclists came from the asymmetry. You can see in the photo, this is the typical situation in a cyclist, which his position over the bike is asymmetrical. And this kind of problems make that the cyclist can injure, or they can lose power during the pedaling. We have been measuring all this type of asymmetries with IMU, inertial movement units, or with other kind of tools. For example, this is one of them, WIVA. This is the IMU, and give us information about the pelvis over the saddle. It gave us data about the obliquity, for example, how the pelvis is moving over the left and the right on the saddle, or data about the rotation of the pelvis. We are measuring this kind of movement, and we can know how the pelvis is moving over the saddle when the cyclist is pedaling. Other types of tools that we use is MG. This is a video. This is surface MG, and give us information about the muscular activity during the pedaling. Which this types of tool we can see for example, how the muscles are working on the right leg and in the left leg, and we can see the difference between both legs. Here you have another video. You can see the difference between left and right. In this case, 52% and 48%, and how the quads are working or the hamstring are working. John has been working with NG for a time, and I think that he can tell us his experiences with this kind of tools.
Yeah, thanks, Javier. Yeah, just make note to the public that they are looking. Some of those images are recorded on the lab, but several times we use also those devices outside. Maybe it's not related directly with today's topics, but it's quite interesting that the most of our experience recording cyclists and related with the asymmetry has been indoor and also outdoor. So we got a huge and a very big screen about the topic that we are developing today. On this screen, you can see, for example, the classic recording of the kinetic data of in this case, the Pioneer power meter with the tangential force and the radial force. In these two starting examples, you can see that the red and the blue lines, that means the right and the left legs, they do very different things during the pedaling, and this is one of our most iconic visions in the social media when we are trying to explaining this to the people and mainly to the public to make them understand that the pedaling is not symmetric, and which are more or less the consequences of the sensation that they got over the bicycle related with the things that we are able for measuring on the bicycle, as I said, on the lab or maybe outside the lab. So you can follow yourself, Javier.
About asymmetries, what kind of asymmetries we can find in general in the most of the case that they come to a studio. For example, I don't know if you can see okay, this time lateral pelvic, there is one of the bones of the hips is up than the others. Other time we have rotation of the pelvic, the pelvis, or this kind. There are the more common problems, and you can imagine that the bike is symmetric, and if the cyclist is not symmetric over the bike, the problem starts. And this is the main reason for the injuries over the bike, the asymmetric pelvis over the saddle. Okay. For example, you can see here the difference in the pelvis, the foot in the feet in that case 40-40, and this one 50-30. The reason is the same than the other. There is a pelvic asymmetric, and this situation makes that the pressure in the feet are asymmetrical. This situation, when you are over the bike, the feet over the pedals are asymmetric and makes that the pelvis make asymmetric. So the cyclist is going to be in a bad position again. And here John is going to explain how there is changing compensation too with the muscles.
Yeah, related with the slide that we have seen, and looking after to this picture, we want to make understand to the public that every time that there is any kind of asymmetry on the body, it doesn't matter if it is functional or if it is anatomical discrepancy. What the body does is to try to compensate this to create some equilibrium. So what happens often that after the asymmetry, there is another compensation that often is the origin of the pain, of the place that is focused the pain, but the asymmetry is not coming from this point. And normally what happens that this is somehow show it in another part. So there is a very interesting article talking about this, the relationship between postural asymmetry and cycling injuries of this author, Lord Thomas, that speaks perfectly about how the body does the compensation in very different axles and very different directions. And it's very important for the fitter and for the trainer to understand this kind of mechanism, because once one place is not working as expected from the point of view to side differences, what happens that is another bone or maybe another joint, another muscle of this structure is going to work in the opposite way to try to compensate. So this makes our job to trying to explain and trying to amend this kind of problems really complicated several times, as you will see also on the bibliography.
In our experience, most of the asymmetries that you can find came from this chain compensation, are muscular tighten and most of the time, and it's difficult to find anatomic asymmetries. They came from a broken bones with an accident, because of an accident, or congenital position. Most of them are chain compensation. Here John is going to explain this article that I have said before, that when there is an asymmetry, most of the you can be in risk of injuries.
Yeah, this is a slide with some references that talk about the relationship between asymmetry and injuries in the sport in general. We're not talking right now about cycling, but we did an overview on the bibliography about the question, is the asymmetry pathologic itself, or it is not, and it's something that we could manage without any kind of risk. So in sport in general, it's quite clear after doing this research that the asymmetry, it's very closely related with the injuries in sport in general. And in the next screen, please, Javier. There is one article. It's not a lot of writing literature about cycling injuries and the asymmetry processes, but Andy Pruitt with the colleagues, that they are well-known people involved in cycling from time ago and in fitting too, they speak about this concept as the bicycle design is symmetric and is matches against asymmetric variants. The human body can produce occasionally abnormal directed stress loads on tendons and muscles. Just we want to make note to the attending people that it's probably something that causes more problems that the expected and basic fitting that we have been looking till this moment. So the relationship between the pain and the asymmetry process, that's one of our focus in today's job and also in today's presentation.
Here there is a studio in which one relate between the intensity and asymmetry. Here you can say how the intensity is going to make this, when there is more high intensity, sometimes the power balance make more stable. This that the study explains. And now with WKO4, we are looking that this is not real all the time, and after that we are going to make some examples in which when more intensity, sometimes you are more asymmetric and not more symmetric. We are going to see it later. Here Narion is going to explain this studio about from Bini, which is one of the features that are going a lot of research about this kind of things.
Yeah, this studio is very well known in the research. Is one of the most cited article, and it's relating the asymmetry and the performance with not a lot of subjects, but in a very non-significant relationship. So when we have tried to find information in general about which is the relationship between asymmetry and performance, it's not clear on the literature that the asymmetry cuts or makes any kind of interference on the performance. There is a very high level that they are very symmetric and very asymmetric, and there are low level sporties that they are symmetric and other kind of asymmetric. So there is not relationship between one and the other. Maybe it's needed more follow-up of this process because there's not a lot of information in the research about this matter, but probably is one of the most popular questions from the point of view of the people that is attending, for example, this webinar. Okay, it's related, it's not related. So the bibliography speaks clearly. It's not clear relationship between being more asymmetric and has less performance. That is something that we could expect maybe. It's not demonstrated, it's not significant today on the bibliography.
This study tends to say the same that the other one. In this time, they make a relation between the non-dominant left and dominant left, and say the same that being symmetric doesn't mean have more performance than people that are not symmetric. How can we measure the symmetry? We have the kinetics, the measure of the force. Now we have the dual side power meter, or one side, and a torque, or we have the kinematics. Today we have a different system of motion capture, like ritual. We have motion logic, and with this kind of tools we can measure the kinematics, and we have the variation of the symmetry, the Asymmetry Index, the deviation component, etc. Something to say about here, John? This?
Yeah, maybe we are going to focus after the kinematics on the kinetics because it's much more related with the WKO software from the point of view of the analysis, but related with some slides that we have been seeing before. It's really complicated to define the asymmetry from the point of view of the mechanical and mathematical point of view, because several authors treat the asymmetry in different ways. So you can never compare one study with the other when we are doing, for example, or using the Asymmetry Index, that is one of the most common way of comparing the asymmetry with the coefficient of variation. So they are also different approach from the point of view of the statistic to define which is symmetry and which is not symmetry. We will see on the WKO the differences also between the 50-50 and the Kurtotic Index and the Kurtotic Index and the Asymmetry Index themselves.
Asymmetry and kinematics. In all of this studio, all of them, the conclusion is that the ankle the ankle angle is the key, because when there is an asymmetry, the ankle tends to be the part of the body to start to make compensations of the symmetry. That is the main axis of all of them. And when the ankle is the part of the body to have to control the torque over the bike, and when there is an asymmetry, one of the ankle starts to work in another run, of movement, and that makes that the torque makes asymmetric, as we are going to see with some examples in WKO4. Here you have another study of Jansi explaining the same, that the difference when there is an asymmetry, the main compensation of the body is in the ankle, in the extension and in the flexion of it. And there is another study in which they measure the sprint in the cycling, and at the same time the difference were in the ankle too. So ankle is the key, and we are going to see it with data of WKO4. What happens when we have data with WKO4? This is a chart we have created. If someone wanted, we can send by email. And here we have the evolution of the power balance. You can see it in the bottom how the power balance develops in one season, and here you have the asymmetry index, the torque effectiveness, and the smoothness. So we can control in a season the evolution of the symmetry. So it's very interesting for all of the coaches or fitters have a tool like WKO4 for control of this. It's a lot of information to for explain to our cyclists how pedal better or how to control their asymmetry, or if you have to send him to a fitter to make change and to prevent injuries. Another chart very interesting is the one, the bilateral power duration curve, and we make the following question. Here we have the data of a pro riders, and he has a little asymmetry, and here you have the power duration curve of the left leg and the power duration curve of the right leg and the color blue. You can see that in this point, for example, in close to 1 hour, the left power produced 153 watts and the right leg 140. And the question is, if the cyclist were symmetrical, he will increase his power. What do you think about it, John?
Yeah, I have seen several cases when you try to achieve a better symmetry. You win from the point of view of the performance, but not always from a very visual point of view in watts from one day to the other. It's much more complex process, and several times from my experience, several riders, they don't want to be asymmetric. They don't feel very comfortable being asymmetric, and they just feeling much more better doing 50-50 on the power meter, on the Pioneer, for example, and they just want to be symmetric, and maybe without taking care of another kind of data from the point of view of being more better riders from the point of view of the performance, but just for having a mental relax about this. So it's very complicated to know if the increasing of the performance of one rider, for example, has been because of the training, the normal training, or any other kind of process that is affecting the performance, or just the symmetry. In a high-level sport, in high-level cycling, professional cycling, we are working 10 or 12 people around the cyclist, increasing the stress and the adaptations every day. So it means that obviously we try to achieve the better result ourselves. So the main problem is to try to explain to the people that this has been an increasing on the performance because we have improved the symmetry. Is really complicated because there are another processes that are around doing several different effects as altitude training or maybe another kind of adaptation. So it's really complicated, but I think that this is something that relaxes the rider's mind a lot from the point of view of being 50-50 at the end.
I think that in amateur cyclists or master cyclists it's more easy to improve the performance being symmetric. I think. Do you think that, John, or not?
Yeah, maybe it's because of the same reason, because they got not as much as stress from the point of view of the things that they do for improving the performance. So anything that affects this performance affects a lot from the point of view of the statistic. In the professional rider, it's more complicated because they are trained from years ago, and they are skilled in several things that they are not very easy to change. So probably we are seeing in another studio that I don't mention today here that the change on the biomechanics is more related with the cycling experience that with any other kind of thing. So I mean, the more cyclists you are, the worse is going to be to change the thing. It's quite logic. So the pro riders with who knows, maybe 150 kilometers per year in several seasons, it's they got a very stable motor pattern, and you have to struggle to try to change the way of doing the things. Maybe the young riders, or maybe the not very skilled riders, it is easier probably.
Okay. About the mono and dual sign power meters, you know that the metrics that we are going to explain in WKO4 doesn't work in all of the power meters. Only works in dual side, like rotor, Pioneer, Factor, Garmin. The other mono signal power meters doesn't work all the metrics. So when you are going to see data about your cyclist, you have to check that they have a dual side power meters to see all the data that we are going to explain. The metrics that we use for control the symmetry with WKO4 are power balance, is the power production of each leg. For example, you can see 55-45. That means that the left leg produces 55% of the power and the other one 45. GPR, gross power release, that's the power that you are releasing on each pedal stroke to propel the bicycle forward. We can see that is power production that is useful, or the tangential positive, and the GPA, gross power absorbed. Power that is being produced, but it's not going to moving the bicycle forward. So we can see that is power useless. It doesn't work, for example. Another metric is Kurtotic Index, is how punctual or smooth you are pedaling. This is the ratio between the maximal effective pedal force and the average pedal effective force. And the last one is the Asymmetry Index. That is a relationship between all the metrics, GPR, GPA, and Kurtotic Index. This metric gives us an idea about how symmetric is the cyclist pedaling. Now we are going to see some examples. This is a very interesting chart because with a quick view of this, we can see how the data about the cyclist is developing in a season. We can see the torque effectiveness of both legs, the GPR and both legs, GPA, pardon, the peak of GPR and right and left, the Kurtotic Index of both legs, and the maximal effective pedal force. So with a quick view, we can see if the symmetry is going to how the symmetries is developing in a season. And for example, as I have said before, if we can see that the cycling is going more and more asymmetric, we can send him to a pitcher, for example, and make the change, or give him feedback about his pedaling technique in order to correct all these problems that can occur. About GPR and GPA, you can see here this chart, and I'm going to take the okay. You can see the difference in between left and the right. In this case, left is producing more power than the right. You can see that the blue line is over the red. At the same time, the left is absorbing more power than the right. So you can see here an symmetry. This chart is very useful to check how the power is going to be produced, or how it's producing the power of the cyclist. This one is another, the Zorro chart is so interesting too, because with a quick view you can see how is the pedaling style of the cyclist. Here you can see the gross power release of the right is the dots on red, and the gross power release of the left are quite symmetric, both of them, but in this case you can see that the GPA on the right is over the GPA on the left. This situation, this cyclist is braking, or we can say that like that, with the right leg. that make that the Kurtotic Index in the left is worse than the right. The Kurtotic Index for in general 4 points is a good value, and the lower Kurtotic Index, the best pedaling technique of the cyclist. Okay. This is one of the more common errors of the cyclist, and now John has a lot of experience in that case, and now he's going to explain what is happening in this situation. Okay, John?
Yeah, as you say, this is a very quite topic, and it's a very common question of the riders. How should be the ankling? It's not related with today's topic, but it's very related with the slides that we have been seen before. Wherever you do ankling or you don't do the ankling with the right, with the left, up and down, the main difference of the ankling, as we see on the bibliography, and we can probably confirm this from the point of view of the data that we got, makes a very big difference from the point of view of GPR, GPA, expedition of power. So as you can see here on the diagram of the Pioneer, the difference of the efficiency is very related with the point that the ankle is going to push the pedal. So from 3 to 6 o'clock, there is a big difference from the point of view of using this. And not just that, because during the upstroke on the blue lines, we can see that this brake, the GPA, that is on the left and this is on the right, and makes a very big difference from the point of view of the watts. On the right one, we can see that there are 20 watts that they are lost, that they are braking the pedaling, as they are very, very vertical and very tangential to the direction of the pedaling. So this is very different from the point of view of the left, that on the left, this blue line is quite radial, it's not tangential, so it means that it's loosed as inertia and it's not loosed as the braking. So it makes just 12 watts from the point of view of the braking. Those numbers are quite common, and it's a very common mistake of the cycling. I have seen this kind of mistake both in best riders, professional riders, but also in low-level riders. So it's not related probably with the rider's performance, but just with the use of the ankle during the pedaling.
Something very interesting in here is you can see that the power balance is 50-50, but the asymmetry index is 0.77. The power production say that it's the 50-50, but the right one is producing much more power, but at the same time is absorbing. So the cyclist is not working symmetric, despite the power balance says that is 50-50. Okay, so sometimes we see cyclists that they have a symmetrical position over the saddle, and they said, no, my power meter said that I am working 50-50. So these are very common situations. Now John is going to explain here he has explained it, the tangential and radial force when ankling. He has explained in the slide before, and when the cyclist is ankling, you can see how the radial force increase. So that means that the GPA is increasing. So the cyclist is like braking the pedals when he is producing power. Okay. Now John is going to explain one of the case that is very common to the left length discrepancy.
Yeah, it's very common on the fitting to have customers, cyclists, that they complain about a leg discrepancy, maybe anatomical or maybe it is functional. And about this, there is a big review, and what's said on this review that the leg discrepancy is nothing natural, and it's very related from the point of view of the statistics, and this is a meta-analysis, so it's not just an isolated studio, it's the compilation of a lot of studios. When it's said that the asymmetry produced by the leg discrepancy is related with scoliosis, low back pain, osteoarthritis in the hip and the spine, accepted loosening of hip prostheses, and lower extremity stress fractures. Some of them, they are not very common on cycling as injuries, but the low back pain and the scoliosis are very, very, very common in our studios.
Now here you can see the typical case of leg discrepancy. You see some information, for example, the power balance, 45-55, and in this case, the right leg is producing more power than the left because of this leg discrepancy, but the GPA is the same. In this case, it was a professional rider who has an accident with her in the pelvis, and the right femur was shorter than the left. Pardon, the left femur was shorter than the right. So that means that the power production of the right was higher than the left. So this is one of the example of leg discrepancy. Now you can see again what happens if we put, for example, a shim for this type of discrepancy, and the GPR makes equal because we are compensating this problem which has shim, and there is no leg discrepancy. This is another case that is very typical. John, you can explain us this case?
Yeah. This is one of the started things that we mention a lot of times to the riders. It's one of the most complicated cases to try to solve on the fitness studio, because several times the motor pattern of the rider over a saddle is as twisted and is probably losing the perception of the seat bones over the saddle, and happens what we can see on the photograph, that the chamois is mainly out of the saddle, or maybe we could see or expect that the right ischion is over the saddle and the left one is completely on the air. So it means that it's going to be a rotation of the pelvic bone. Also could be a potential injury on the low back pain, probably on the right, and it's going to have problems also on the right front part of the quadriceps. It's related with this position. We see this quite often. From the point of view of the WKO, we see that there is a very big discrepancy on the power on the legs, where mainly the problem is related with the power production that is much more bigger on the left than on the right. This is because, as we saw on the third slide of this presentation, a lot of body mass is over the left leg and not on the right. So as our point of pressure to push in the pedals is the upper part of the body, when the upper part of the body is not symmetric over the pedals, it's quite impossible to make a strength at the same level with both legs. So it's quite sided rider, and when there is more rider, in this case on the left, is able for pushing more on the left than on the right. Other phenomenon that happens here, because it's very complex phenomenon, is what we can see on the Pioneer diagram on the right. There is not a breaking on the upstroke when the intensity of 239 watts is not extremely high. It's a medium intensity, but it's not breaking with the upstroke of the right one. And this is happening because as the left ischion is on the air and it's folded to the left, it's pulling up with the weight of the leg upside. It's not able for doing with the left one, but it's happening with the right one. Then this is one of the most common thing that we can see. On this way, we could say, oh, okay, it's perfect because the GPA of the right one is 8, so it's not breaking so much. But it's absolutely tricky because the pelvic bow is not symmetric over the saddle. So on this case, this kind of potential good evaluation of the pedaling on the right is absolutely bad, and probably it's becoming an injury because the left one is doing the most of the downstroke, as we can see on the GPRL. And these kind of situations, it's very common in our studios, and the people that mostly come to our studios, they come complaining about problems related with this. So it means that this statistically maybe is not very significant, but very significant from the point of view of the amount of customers that comes to us with this, as we are using WKO in this case to doing the evaluation, and not just the evaluation starting one, but also the control during the season or after the bike fitting process of the re-education of the position of the pelvic wall over the saddle.
This is the same situation, and you can see that the power production in GPR is different. Here the blue line is over the red, and the green line GPA of the left is over the right. It's the same situation that the other one in these charts. And that John has said is a complex case because when you achieve that the cyclist is in a symmetric position over the saddle, now he has to relearn how to pedal because he keeps pulling with one leg and pushing with the other, and this part is the more difficult for the fitters. Tell the cyclist how to pedal correctly. Okay, and now John is going to explain the influence of the pedaling rate, the cadence in the asymmetrical cyclings, because there are some studies talking about that, and now we are going to explain our experience with WKO4 for this situation with some of the cyclists that we train.
Yeah, from the point of view of the bibliography, because it's very important to know what's said on science before starting doing any kind of hypothesis with our studios. We try to get the most relevant information, and we can see that there is not relationship with the cadence and the asymmetry. We were expecting to have some relationship in our cases of our riders, but the science said that sometimes when the cadence grow up, the asymmetry grows also, and other kinds with other subjects, when the cadence is upper, the asymmetry is less. So it means that it's not a significant relationship between the cadence in general and the asymmetry process. And this is one of the most mentioned and most successful studies from the point of view of explaining this, because it's really well done. And the conclusion of this study is that we have to take each case of our riders maybe in a different way from the other. So we cannot give general conclusions about how to pedal from the point of view of the cadence, go faster, go slower, because we have to evaluate if this rider is going to go better with a bigger cadence or is going to go worse with a bigger cadence. So it's very individual, and there is not a general recommendation. We are going to see several cases about this on the examples. Please, Javier.
As John has said, that the study explained that there is no much relationship between cadence and asymmetry. That is very individual. But we have observed some case in some cyclists. For example, this one, the cyclist told us that when he was climbing, the asymmetry appears. You can see here that he has 46.54, 1.55 asymmetry index when he was climbing. Probably the motor control of this cyclist was bad. It was not optimal, and he climbs with a high cadence. He doesn't control the pedaling, and that makes that he was absorbing so much power with the left left. So we told the cyclist to lower the cadence when climbing from 84 to 72, and we see that he was much more symmetric. In this case, the asymmetric index low and the GPA in both legs were more equal. It's a case that is sometimes common in cyclists with low level that try to pedals in cadence that they are not used to do it. I think that John agreed with me that in this kind of case, no?
Yeah, as any other human movement, if you are learning to doing the things, the faster that you do them, the more possibilities that you got of doing mistakes on them. It's as playing a music instrument. It's exactly the same. So from the point of view of the development of the motor pattern, if you start with a slower cadences, you are going to learn better, and your brain is going to control better the movement. And the more skilled you are from the point of view of the experience, and the more pedaling you, this cadence is going to increase in the proper way. If you increase the cadence, maybe not attending to the good control of the movement, what happens, what we can see, is what's said on the studios. The adaptations are there are very individual, but for example, the ankles, they are not working properly. Seems that it's very easy to control the ankle, but the science says exactly the opposite. We are not very skilled in controlling the ankle when we are cycling, and we are quite asymmetric because the ankle is the most asymmetric thing that we use, probably related also with the cadence.
And now John told us about the difference with leg dominance at different intensities. There are so much people that think when they come to the studio that if pedaling asymmetrics came because they have, for example, more dominance with the right left or the left.
Yeah, this very relevant study of Felipe Carpes from Brazil speaks about the neuromuscular adaptations related with the leg dominance. This is probably the work group more skilled about this topic from the point of view of the research, and they have been struggling to get some relationship between the leg dominance and the asymmetry. That is one of the factors that one could expect to be more or less interesting from the point of view explaining, okay, I use more the right, so I'm more skilled with the right, my right is pedaling better, and the opposite with the left one. So what seems that the leg dominance itself doesn't explain never why there are so big difference from the point of view of the pedaling. There is right people that pedals better or faster or maybe stronger with the left, and the opposite one. But it's very important to know this because it's one of the most common explanation that the customer tell to us. So yeah, I feel more stronger with the right because I use the right for everything, so it's more skilled. And maybe this is not the reason. Maybe on one case could be, but it's not in general the explanation of the asymmetry in the cycling cases.
Here in this study about Juan García López explained the same conclusion about that there was no significant difference between dominant and non-dominant in asymmetries. So we explained the same, and this is the answer for all the cyclists that told us, I think that I make more power with the right because I use it more. So when someone ask you about this kind of situation, you have the information for telling him that there is no significant difference between left and right and dominance. Here are another study that's saying the same about Ranama and Port. And now John, who has a lot of data about pro cyclists of Lotto Jumbo, can tell us how the asymmetry can can vary day by day because it's not stable over the time. I think that have a lot of factors like physical condition, no, John?
Yeah, it's a lot of things involved at the same time, and what happens is that the reversibility of the asymmetry is quite common, and we can see from the statistics point of view that the day-to-day reliability of the index is just 0.47, and within the day reliability was up to 0.87. So it means that we are not very stable in our asymmetries and can be something changeable from one day to another day. So this is makes much more complicated to do several things. For example, to make any kind of research, because you test today one asymmetry and maybe that asymmetry tomorrow is going to change. Maybe you are doing exactly the same condition, but by several reasons this asymmetry is going to disappear. Other times we are going to see 2 or 3 examples. They are very constant and they maintain during the whole year being asymmetric, and the rest of riders, they can do some change after the bike feeding process, for example, at the start of the season. So this is making really explaining in a very easy way, complicated to manage, but then we got the WKO software that helps a lot, taking an overview from day-to-day changes, and we are going to see examples of riders that they change the asymmetry during the season, and other riders that they amend it, and there are riders that they are not going to amend the asymmetry during the whole season.
In our experience too, the fatigue has a very influence. For example, cyclists who has a good power balance, they make a hard workout, and the following day they are not so symmetric. That's the reason, because they have some fatigue, and the muscles are in different are tightened, for example, and they lost a little of motor control, for example. That is the case that we explained before. It's possible being asymmetric and 50-50 power balance. Yes, you can see here the example of the cyclist. Power balance was 50-50, but the asymmetric index was not. And you can see here that he's producing more power with the left leg, but at the same time he's absorbing much more power with the left than the right. That means that his motor pattern has changed, because he's pulling with one leg and pushing more with the other one. He's probably asymmetric over the saddle, and the motor control has changed, and his pedaling technique is not optimal. What is the gold standard or the situation that everyone wants to achieve? This one, 50-50 power balance, asymmetry index 1.0, and equal power gross power release in both legs, and equal gross power absorbed. This is the gold standard that every cyclist want to achieve. John has explained before that symmetry, there is reversibility over the time. We can find cyclists that has a good symmetry, but during the season it can change. You can see here, in this case, how, for example, the Kurtotic Index has improved a little. Remember that the lower Kurtotic Index, more efficient is the pedaling. And here the different situation. You can see how the Kurtotic Index is increasing here, so he's pedaling worse, but after that started to improve. So the pedaling technique of the cyclist can change over the time, and with WKO4 you can check it during the session. It gives us a lot of information. John, what can you tell us about asymmetry and age?
Yeah, I found this study very interesting because it's explaining one complex concept that probably we should take care in interpretation. The study is quite easy, but the conclusions and the application of this research could be really wide and not well understood by everybody. I mean, on this study they compare the age of the cyclist and the asymmetry index, and they conclude that it's very, very significant that the younger you are and the less experienced you are as a human, not as a cyclist, the asymmetry and the more asymmetry index that you got, and the more skilled people is less asymmetric than in the young ages. It means that probably we can hypothesize that the several cyclists that they don't have developed the motor pattern in the proper way as a humans, probably they are not very able because they are immature from the point of view of the motor pattern. So your general coordination, your capacity for equilibrium and the control of your own segments could be key from the point of view outside of the bicycle to achieve a good pedaling technique. This maybe makes sense, but it's very important to put it on the table that a lot of people that is coming to the bicycle, maybe they don't have a good motor control of the body and they go to the bicycle maybe suspecting that they could pedal in the proper way because it seems from outside that it's quite easy. And as we can see here and in our experience, we are very convinced that pedaling in the proper way is not as easy as is said from outside and or maybe mention it from outside, and it's a very complex phenomenon from the point of view of doing it right in the proper way and in the most effective way. So for me this studio is quite important from the point of view of knowing, okay, where is the place that we should touch the key for trying to amend those kind of problems from the start, on telling to the people what to do. Maybe this is related with something that is much more complex than bike fitting.
What about the future? This is one of the solution for complex situation in asymmetry. I think that John is now working with this kind of things related to neuromuscular aspects, no, John? An activation of units.
Yeah, the firing of the muscles, the coordination of each muscle when it is pedaling could be key from the point of view of making the difference of a good pedaling or a bad pedaling. And maybe there are difference to the right and left leg, and very different patterns from the point of view of different subjects. But as I agree with Felipe Carpes on this, that probably it's not just what we change from the bicycle in the fitting, but also how the brain makes the interpretation of the change of the muscles that should be working or should be not working on any different kind of change of movement when we do the bike fitting, for example. So we could expect that we are doing a very big intervention from the point of view of the change of the muscles, but I'm not as sure of that. I believe more, as is said here, that the way of changing the way of working of the muscles of each subject is going to be key on the future to try to amend problems, to try to, as you said, Javier, teach to the people how to pedal, what they do in the not proper way, and what can be from the point of view of the injury is dangerous for the footer, and this kind of thing. So it will be as a second level in the bike fitting, in the way of telling the people, okay, you should change your way of pedaling, but not because I'm going to put it on upper and lower in your saddle. You have to change your way of moving the legs probably to try to amend the problems that you got, as for example, asymmetries.
As John has said, the next step in fitting is teaching the cyclist how to pedal, and with WKO4 we can diagnose the asymmetry, and we have to give feedback to the cyclist about how he has to pedal to improve his symmetry. Here we have a case of study. This is one cyclist who came to the studio because he has an asymmetry. He says that in his power meter the power balance was 46.54 and the asymmetry index 1.11. In this case, you can see that the main difference was in power production, gross power release in the right, 142, and in the left, 119. And at the same time, there was more GPA in the right left than the left. So he came to the studio and we started to make the fitting. And at the time that we were making change in the bike, we were measuring with WKO4 how that change works or doesn't work. In that case, we correct the saddle height and the setback, the clip position. We use insoles for providing stability to the feet. We change the saddle too because the new ones make the pelvis more stable, and we taught the cyclist how to pedal and send him some exercise to the psoas muscle because it was too tightened. And with the change that we make, we see that the power balance was 48.52, so we improved a little. And in this situation, the gross power were more equal than before, and the difference was in gross power absorbed. The left was absorbing a little more power than the right. So we give the feedback to the cyclist about how to pedal. He will try not to absorb and not to pull with the with the right, and try to pull a little with the left. So after that, a week before, we told him to send some files about his training, his workouts, and a week later, you can see that the power balance was the same, 48.52. The gross power release now was a little higher in the right than in the left, but the GPA was more equal, so he was pulling more or less with the two legs. What happened after 3 months after giving his feedback? The power balance 49.51, the asymmetry index close to 1, and the power production, the power release, both legs was very equal, and the GPA was very equal too. So with WKO4 for all the fitters, it could be a good tool for providing continuous feedback about how the pedaling technique and how to control the asymmetry. So for us, it's a very interesting tool. Now, here we have another case, and in this situation, the cyclist was a big asymmetry, 56.44 power balance, and after the fitting here, you can see how the power balance started to make more equal, and he achieved more or less the 50-50. More consequence about the symmetry. The torque effectiveness increased from 70 points to 80 points, more or less, and the smoothness too, from 20 points increase to for 15 points increase to 20 points. So the being more symmetric in this case, it was a cyclist of amateur cyclist. make that the power production was were more effective than before make the fitting. And as a consequence, the Kurtotic Index in both legs improved. He was in values over 5, and at the end of the seasons was close to 4. That we can see that it's a good value for a cyclist. So this is all of the thing that we have told you. You can see here our emails if you want to make any questions. So thanks for all, and thanks John for being here to share knowledge with us.
Okay, thank you very much to you, Javier, to Training Peaks, for inviting us to this event, and thanks everybody for listening to us. We are attending in our emails to your questions and very glad to answer if we are able for doing. As you can see, there is a lot yet for research and understand on the asymmetries, and we hope on the future to have more information for sharing with everybody.